Let's take a moment to familiarize ourselves with the interface. There are 6 tabs located just beneath the menu bar: Building, Interiors, Landscape, Terrain, Analyze, and Help. These are actually toolbars displayed in tabbed format. They provide you with instant access to the tools you need when you need them. The Building toolbar contains the tools you need to build a home or any architectural structure. It includes tools such as walls, doors, windows, and roof. The Interiors toolbar contains the tools you need to furnish, decorate, and equip the interior of your home. It contains tools such as cabinets, appliances, furniture, lighting, and plumbing fixtures. The Landscape toolbar contains all the tools you need to create a complete landscape plan for the interiors of your home. Tools include plants, fences and gates, decks, and irrigation. The Terrain toolbar contains tools that you can use to recreate the topography of your building site, which is especially important in 3D views. Use tools such as hills and valleys, slopes and plateaus. Add hardscaping elements such as paths, paths, and retaining walls. The Analyze toolbar provides instant access to a variety of tools. You can view area and perimeter calculations for different levels and areas or rooms in your model. The Help toolbar contains instant links to the program help and glossary of terms. You can also control the display of the tutor, which pops up when you use program tools, and the startup screen that you see when the program is starting. The View Control toolbar at the bottom of the screen contains several essential view-related tools. The toolbar's Building Location drop box displays the current building location, which is important when inserting elements in your drawing. The toolbar also lets you quickly switch between 2D view and 3D view and view and create elevations and sections. A Display Mode button lets you choose the current display type for the view. Wireframe, hidden line, and pattern are just a few examples. The toolbar also provides instant access to the View Manager, where you can create new view windows if you want. Zoom tools on the Zoom and Navigate toolbar include Zoom In, Zoom Out, Zoom Real Time, Zoom Window, Zoom Previous, and Pan. The navigation features on the toolbar, Walk Around, Fly Around, Look Around, and Reset Camera, are only active when you are in a 3D view. These tools let you change the view in real time using your mouse. The most common viewing and navigation tools can also be found on the on-screen navigator, which is kind of like a video game controller. It lets you switch between 2D and 3D, zoom and pan, and navigate in 3D, all from a simple control panel displayed on the screen. Motion is controlled by clicking and dragging the center trackball. The commander lets you enter precise values when inserting or editing elements. Initially, the commander will look grayed out because it is inactive. It will become active when you insert or edit elements. By default, a grid is displayed in the drawing area. This set of vertical and horizontal lines is simply an on-screen visual aid that helps you orient objects to one another. The distance between grid lines is 4 feet. The grid can be turned off if desired, and you can control the grid spacing and appearance in your program settings. By default, the grid snap is also turned on. This feature snaps your pointer to an invisible grid when inserting elements. The default grid snap spacing is 1 inch. You can control the spacing of the grid as well as turn the grid snap off if you want to. You can also match the snap grid to the visible drawing grid by editing your program settings. If you are drawing an element, such as a wall, and need to scroll the drawing area to be able to finish drawing the element, simply press and hold the Control key when your cursor is near the edge of the drawing area. This activates the Auto Scroll feature and scrolls the drawing area in the direction in which you move your mouse, allowing uninterrupted drawing. The Catalog panel displays the elements contained in the program's master catalog, or whatever catalog is currently open. This is where you select items to insert into your drawing. The status bar is located at the bottom of the screen. It displays helpful prompts while you are working on your design project. For example, if you're inserting a wall, it may display Pick First Insertion Point. The status bar also includes a selection of drawing aid buttons such as Ortho and Object Snap. Once you familiarize yourself with the interface, you're ready to start your first project. Before you begin, make sure you have a new blank project. Select File and New. Select one of the available templates to begin your new project, and then select Create. When you insert an element in your drawing, it is inserted on the current building location. It is important to define your building locations before inserting elements. Select Settings, Building Locations. Note the settings in the Building Locations dialog. You can edit the settings for the existing locations as well as create new locations. When you define building locations, you're basically doing two things. 1. Setting the wall height for each floor level in your model, and 2. Specifying where each floor is positioned relative to grade or another building location. Click OK once you reviewed the building locations to accept the default settings. Before you start drawing, you need to make sure that you're using the correct unit of measure for your project, and select a level of precision for your measurements. Select Settings, Program Settings. In the Program Settings dialog, select Units of Measure in the left pane. Make sure that Imperial Radio button is selected and that Feet Inches is selected in the Units drop box. Click the Precision drop box below the Units drop box and select a full feet and inches option. This is a good setting for this tutorial. Let's define a new grid snap spacing. In the Program Settings dialog, select Drawing Aids in the left pane. Make sure that the Grid Snap checkbox is enabled, as well as the Custom Spacing radio button below that. Highlight the value in the X edit box and then type 12. Do the same in the Y edit box. This defines a grid snap spacing of 12 inches, 1 foot. Click OK. You're ready to draw. Now you're ready to start drawing. We're going to create a simple exterior wall layout. Look at the View Control toolbar and make sure the current location is the ground floor. Make sure the ortho is enabled on the status bar below the drawing area. This will constrain your walls to 90-degree angles. Select Insert, Walls, Walls, or click the Walls button on the building toolbar. If the tutor window pops up, enable the Don't Show the Tutor Again checkbox at the bottom of the window. Then close the window. This will keep the tutor off while you're completing the tutorial. The tutor is a context-sensitive help aid that pops up when you select most tools. You can turn it back on again later by selecting Help Tutor. In the Catalog panel on the right side of the screen, select the 2x6 brick wall in the Masonry Veneer folder. Move your pointer into the drawing area, then click a point near the lower left quadrant of the drawing area. Without dragging, move your pointer to the right and watch the on-screen dimensions as you stretch the wall. When the dimension reads 25 feet, click to select the wall's endpoint. Move your pointer upward. When the dimension reads 10 feet, click to select the wall's endpoint. Start moving your pointer to the right. This time, type 20 feet and press Enter, making sure that you include the foot symbol after the 20. To type the feet symbol, hit the quotation mark key on your keyboard. If you do not include the foot sign when typing a value, the value will be taken as inches. This illustrates another example of drawing walls where you can type precise values. As you type the value, it appears in the Distance edit box of the Commander, and the angle appears in the Direction edit box. Start moving your pointer upward. Type 20 feet and press Enter. Move your pointer to the left. Type 45 feet and press Enter. Hover your cursor over the original start point. When you see the intersection snap icon, click to finish the layout. Right-click and select Finish. Because we created a closed wall layout using a wall type with composite properties, the walls automatically become composite walls. A composite wall is a structural wall and veneer wall put together with an airspace in between. Select File, Save. Here's a little tip. If you make a mistake or change your mind about something, simply select Edit, Undo, or press Ctrl-Z. You can undo until the last time you saved. To cancel out of a task or dialog, just press the Escape key on your keyboard. Click on the bottom wall. Notice that the exterior dimension on this wall is not 25 feet, which is the value we used when drawing the wall. That is because walls are drawn on center when you use the Walls tool. Click on the bottom exterior dimension value. In the Edit Dimension dialog, type 25 feet. Then make sure that the left-hand arrow is selected so that the left end of the wall adjusts instead of the right end. Press Enter or click OK. The wall layout adjusts automatically, so that the bottom wall measures exactly 25 feet on the exterior face. Press Escape on your keyboard to hide the dimensions. Now let's look at another way of editing the dimensions of your wall layout. Click on the top exterior wall. Notice that the dimension on the right side of the model is not 20 feet. Position your pointer over the top wall's center blue grip, then click and drag the wall downward. When the dimension on the right side of the model is closer to 20 feet, release your mouse button. The wall layout is adjusted again. Before we continue, let's maximize the view. Select View, Zoom and Navigate, Zoom Window. Click and hold down your left mouse button on the top left corner of the model, then drag diagonally to the bottom right corner of the model to form a selection window around the model. Release your mouse button to perform the zoom. Turn the grid snap off by clicking the grid snap button on the status bar. Now let's continue with the interior walls. We're going to draw 4 of them. In the catalog, double-click the Interior Framed Partitions folder. Then, in the folder, double-click the Wood Framed folder. In the Wood Framed folder, select the 2x4 interior wall. Hover your cursor over the bottom right-hand corner. When you see a small black square pop up, which is a snap point, click to select that point. Then click inside the top wall to create the first wall. To insert the next wall, we're going to enter a precise offset. Right-click in the drawing area and select Enter Insertion Offset. In the dialog box that appears, type 14 feet. Then press Enter or click OK. Position your cursor slightly below the top left-hand corner of the model. A 14-foot dimension appears. Click to select the wall start point. Then start moving your cursor to the right. Type 14 feet and press Enter to create a 14-foot wall 14 feet away from the corner. Right-click and select Repeat. This lets you start a new wall elsewhere instead of continuing from the current one. Select a point near the midpoint of our original first interior wall. Start moving your pointer to the right, then type 10 feet and press Enter to create the next wall. Continuing from the end of that wall, click in the lower exterior wall to create our last interior wall. Right-click and select Finish. Click on the vertical wall that we just finished creating. In the Edit Dimension dialog, change the dimension to 8 feet and make sure that the down arrow is selected. We want to make sure that the lower endpoint adjusts and not the top endpoint. Click OK. The length of the wall is now exactly 8 feet. Press Escape to deselect everything. Your walls are complete. Save the drawing. You can insert a variety of doors with point-and-click simplicity. Because doors are intelligent elements, they fit themselves into walls and become part of them automatically. However, you can edit doors separately from the walls that contain them. We'll insert 3 doors in our design. Select Insert Doors, or select the Building Toolbar tab and select the Doors button. In the catalog, open the Entry 2x6 Wall folder, then open the With Single Side Light subfolder. Select the 32-inch solid wood door with side light. Right-click and select Center on Wall. Position the door in the wall that is vertical on the exterior. While you are positioning the door, you may need to pull to the left slightly to get the door to swing to the inside of the model. Notice that the door is automatically centered in the wall for you. Click to insert the door. In the catalog, open the French Doors folder and then the Double Door subfolder. Select the 60-inch double French door. Position the door in the top exterior wall. Dimensions appear on either side of the door. When the right-hand dimension reads approximately 2 feet, click to insert the door. In the catalog, open the Hinged folder and select the 30-inch hinged door 6 panel. In the drawing area, right-click and select Enter Insertion Offset. In the Enter Insertion Offset dialog, type 4 and press Enter or click OK. Position the door in the wall on the interior. It snaps into place exactly 4 inches from the end of the wall. Click to insert the door. Right-click and select Finish. The flip swing command lets you instantly flip a door's hinge side. Let's do this now. Click on the front door. Right-click in the drawing area and select Flip Swing. The swing is flipped. Here's a good tip for you. If you need to flip a door around so that it's swinging on the other side of the wall, use the Flip Opening tool on the right-click menu. To move a door, you can simply click and drag it within the wall, or edit the on-screen dimensions around it. Let's move the front door. Click on the front entry door to select it. Dimensions appear around the door. Click on the top right dimension. In the Edit Dimension dialog, type 2 foot 10 and press Enter or click OK. The door is moved. Press Escape or click in blank space to deselect the door, then save the drawing. We're going to insert 6 windows in our model. Select Insert, Windows, or click the Windows button on the Building toolbar. In the catalog, open the double casement folder, then select the 4 foot 9 by 4 foot double casement window. In the drawing area, right-click and select Center on Wall. For this exercise, pull slightly towards the inside of the model when positioning each window so that the window is inside the stud wall. Insert them. The windows centered on the front wall. We'll insert 3 of them here. On the right-hand front wall, we'll insert 1 in each of the rooms. And on the rear exterior wall, we'll insert 1 to the right. Right-click and select Finish. Save the drawing. Here's a tool tip for you. If necessary, you can use the Flip Opening tool on a Windows right-click menu to flip the window around after you have inserted it. An opening is simply a cutout in a wall or a pass-through. You insert openings in the same way that you insert doors and windows. Let's insert an opening now. Select Insert, Openings, or click the Opening button on the Building toolbar. In the catalog, open the Arched Doorways folder, then select the 3-foot arch top doorway. Position the opening in the upper interior vertical wall. Then click to insert it. Right-click and select Finish. Save the drawing. Let's take a look at what we've done so far in 3D. There are various tools available for viewing in 3D, including 3D Quick View and 3D Camera. The 3D Quick View tool lets you choose a preset view angle for quick 3D viewing. Select View, 3D Quick View, or click the 3D Quick View button on the View Control toolbar. The 3D Quick View button is also available on the Navigator controller. In the 3D Quick View dialog, or on the Navigator's control pad, click the lower right arrow. The model is displayed in 3D from a southeast viewpoint. The 3D Camera tool displays a 3D perspective view of your model, which you can adjust by controlling the view's camera. Interactive camera settings are displayed in the panel on the right side of the screen while the camera view is active. Select View, 3D Cameras, 3D Perspective, or click the 3D Cameras button on the View Control toolbar and select 3D Perspective. The 3D Camera button is also available on the Navigator. In a 3D perspective view, the scale of an element decreases according to its distance from the viewer, creating a more realistic view. Not only can you view in 3D, but you can also move around in 3D using a variety of real-time navigation tools. Navigation tools are available on the View menu and Zoom and Navigate toolbar, but you may prefer to use the on-screen navigator instead. The choice is yours. The Walk Around tool lets you walk forward, backward, left or right while in a 3D camera view. You can even walk inside the model. Let's walk around and take a look at the model now. Make sure you're still in a 3D perspective camera view. Select View, Zoom and Navigate, Walk Around, or click the Walk Around button on the Zoom and Navigate toolbar. If you prefer to control your navigation with the Navigator, click the Walk button on the Navigator. Click and hold down your mouse button, then drag to walk around. If you use the menu or toolbar to activate the Walk tool, click and drag in the drawing area. If you activated the Walk tool on the Navigator, click and drag the Navigator's central trackball. To walk forward, drag upward. To walk backward, drag downward. To walk left or right, drag left or right. The Fly Around tool revolves the camera around the target, which by default is at the center of the model. This creates a spinning effect. Select View, Zoom and Navigate, Fly Around, or click the Fly Around button on the Zoom and Navigate toolbar or on the navigator. Click and hold down your mouse button, then drag to fly around. In a 3D camera view, the Look Around tool revolves the target around the camera. Select View, Zoom and Navigate, Look Around, or click the Look Around button on the Zoom and Navigate toolbar or in the navigator. Click and hold down your mouse button, then drag to look around. If you've moved the camera or lost your orientation in your 3D model, you can use the Reset Camera tool to move the camera back to the position it was before you started navigating around. To reset the camera, select View, Zoom and Navigate, Reset Camera, or click the Reset Camera button on the Zoom and Navigate toolbar. When you're in a 3D view or elevation view, you can switch back to 2D plan view at any time using the 2D plan tool. Let's do this now using one of 4 available methods. Click the 2D plan button on the View Control toolbar, or click the 2D plan button on the navigator, or select View 2D Plan, or right-click in the drawing area and select 2D Plan. By default, a floor is inserted automatically when you create a closed wall layout. Initially, the floor spans the entire model and then splits into individual floors as you create rooms inside the model. By default, the floor type inserted is a wood frame floor with hardwood flooring. You can customize floors in your model in many ways. We're going to change the floor in the bathroom to a tiled floor. Floors are not visible or selectable in 2D wireframe view because the floor edge lines can interfere with the display of the wall lines. You can use the 2D Designer's Plan tool to quickly display a rendered version of the 2D plan. In this view, you can see and select floors. Select View, 2D Designer's Plan, or click the 2D Designer's Plan button on the View Control toolbar. Now let's change the hardwood flooring in the bathroom to tiled flooring. We can do this quickly with the Materials Paintbrush. With the 2D Designer's View still active, select Edit, Materials Paintbrush, or click the Materials Paintbrush button on the Tab toolbar. The panel on the right side of the screen displays the Materials Library. In the Materials Library, scroll down in the Groups pane and select the Tile Generic Group. In the Materials pane, select a tile that you'd like to use in the bathroom. Click inside the smallest room the tile is applied to the floor. Right-click and select Finish. Let's insert a ceiling in each room of your model using the Ceiling by Room tool. Select Insert, Ceilings, Ceiling by Room, or click the Ceilings button on the Building toolbar and select Ceiling by Room. In the catalog, open the Unframed folder and select the 1/2-inch drywall ceiling. Click inside the left room. A ceiling is inserted. Insert a ceiling in each of the other 2 rooms and then right-click and select Finish. Inserting a roof couldn't be easier. All it takes is 1 mouse click. Select Insert, Roofs, Roof by Perimeter, or click the Roofs button on the Building toolbar. In the catalog, select the 8/12 slope hip roof with shingles. Click anywhere inside the model. The roof is automatically inserted. Roof surface edges are represented by our dashed line. Once you've inserted a roof, you can edit the properties of each roof segment individually to create a complex roof with varying pitches, styles, and plate heights. For example, you can convert a hip end to a gable end, edit the support height, edit the overhang distance, edit the slope, and control the appearance of fascias, soffits, and gables. We're going to convert 2 of the roof's hip edges to gable ends by editing the properties of the selected roof edges. Select View, 3D Quick View, or click the 3D Quick View button on the View Control toolbar. In the 3D Quick View dialog, click the lower left arrow. Click on the very front roof edge. A green arrow projects from the plate line of this roof edge. Red arrows project from all other plate lines. Click on the red arrow projecting from the plate line on the right side of the model. It will turn green also. A green arrow indicates that a particular roof edge is selected and will receive changes you subsequently make. Edges marked with a red arrow will not be changed. Right-click and select Properties. In the Roofs dialog, click on the button in the Roof Shape area, which is currently set to Hip. In the Roof Shape dialog, click on the Gable option. Back in the Roofs dialog, select the Support and Details tab. In the Gable area, select Squared from the Type drop box, then type 12 in the horizontal edit box. Click OK. The selected roof edges are now gables. You can view front, back, and side elevations of your model with a couple of mouse clicks. There are 4 default elevations available. You can modify the properties of these elevations or create new ones on the fly. As you edit your model in other views, elevation views update automatically. Let's view a front elevation of our model now. Select View, Elevations, Front Elevation, or click the down arrow next to the Elevations button on the View Control toolbar and select Front Elevation. By default, elevations are displayed in Hidden Line mode. Select View, Display Mode, or click the down arrow next to the Display Mode button on the View Control toolbar. Then select Pattern. This displays material patterns such as shingles and brick. In the next exercise, we're going to work on the interior of the model. So let's hide the roof from view to make that easier. Select View, 2D Plan, or click the 2D Plan button on the View Control toolbar or the navigator. Select View, View Filters, View Filter, or click the View Filter button on the View Control toolbar. In the View Filter dialog, click the eye icon next to the roofs item. Click OK. The roof is hidden from view. Using the Kitchen Builder wizard, you can quickly and easily create a kitchen layout that includes upper and lower cabinets, a sink, refrigerator, and stove. There are a number of layouts and styles to choose from. Once the kitchen has been created, you can move, edit, and delete items, as well as add more elements if you want. Let's create a kitchen now. Select View, Zoom and Navigate, Zoom Window. Then click and drag a selection window around the kitchen to zoom in on the kitchen area. The kitchen is in the rear left room with the French door. Select Insert, Design Wizards, Kitchen Builder. On the first Kitchen Builder wizard screen, click Next. On the General Kitchen screen, click the U-shaped style, then click Next. On the General Kitchen Layout screen, select the top right kitchen layout, then click Next. Remember that you can move and edit things later. On the General Kitchen Theme screen, select a theme for the kitchen, then click Next. The selection you make determines the materials used for the cupboards and countertops. On the Kitchen Rotation screen, select the top right rotation option, then click Next. Click Finish. The kitchen configuration is attached to your cursor. Position the kitchen layout in the lower left corner of the kitchen area. It will automatically snap to the walls when you get close to them. Click to anchor the kitchen elements. Dynamic dimensions are displayed to show the size of the layout. Move your cursor toward the upper right corner of the kitchen to stretch the layout. Stretch it until the kitchen touches the rear exterior wall and the lower run of cabinets, meets up with the end of the horizontal interior wall. Once the dimensions are correct, click to finish the insertion. A dialog box appears. Click Yes to finish the task. If you click No, you can reposition the resize the kitchen. Save the drawing. You can create a new 3D view by placing a new camera in your 2D plan view. Once you've inserted the camera, you can specify the camera angle and viewing field angle by rotating and clicking your mouse. Let's start a camera in the kitchen area so that we can see what the kitchen looks like in 3D. Select View, 3D Cameras, Place New Camera. Or you can click the 3D Cameras button on the View Control toolbar and select Place New Camera. Click in front of the French doors to insert the camera. Then click near the sink to indicate the target of the view. The 3D view is created instantly. Light fixtures are one of the many different elements that you can use to enhance your design. You can insert a variety of light fixtures and see lighting effects in real time as you insert them. Light fixtures add lighting to a 3D scene, which is important if you plan to generate 3D real view renderings of your home's interior. Since we're in the kitchen, let's insert a light fixture there. Select Insert, Interiors, Interior Lighting, or select the Interiors toolbar tab and click the Interior Lighting button. In the Catalog panel, open the Ceiling Lights General folder and select the Ceiling Fixture 1. Position the light on the kitchen ceiling. Section views are cross-sections through your model. You create one by defining a cut line and reviewing the distance. Let's create one now. Return to 2D Plan view by selecting View, 2D Plan, or clicking the 2D Plan button on the View Control toolbar or the Navigator. Select View, Zoom and Navigate, Zoom Real Time, or click the Zoom Real Time button on the Zoom and Navigate toolbar. Position your cursor in the drawing area. Click and hold your left mouse button, then start dragging downward to start zooming out. When the entire model is visible, release your mouse button. Select View, View Filters, View Filter, or click the View Filter button on the View Control toolbar. In the View Filter dialog, click the icon next to the Roofs item to turn the roof back on. Note that the eye will only be half open. That is because the Roofs item has framing associated with it, but the framing is locked in a hidden state. The half eye indicates that some of an element's components are visible and others are hidden. Click OK. Select View, Sections, Create New Section, or click the Sections button on the View Control toolbar and select Create New Section. Select a point outside the front of the model, and then select a point outside the rear of the model. The cut line is defined. Select a point outside of the left exterior wall. This defines the viewing direction and distance. The section is generated automatically. There are a variety of landscaping tools to help you create a complete landscape plan and design all of your outdoor living areas. These include decks, fences, garden beds, edging, plants, furniture, and lighting. Let's insert a tree in the front yard. Return to the 2D Plan view. Select Insert, Landscape, Plants, or select the Landscape toolbar and click the Plants button. In the catalog, open the Deciduous Trees folder and select Maple. Insert the tree in the front yard. Right-click and select Finish. Now we're ready to start annotating the drawing. Let's add automatic exterior dimensions to the model. Select Tools, Dimensions, Auto Exterior Dimensions. Dimensions automatically appear around the exterior of the model. Room dimensions are commonplace on floor plans and can be calculated and inserted automatically. All you need to do is pick 3 points to define a room's length, width, and rotation. Select Tools, Dimensions, Room Dimensions. Select the inside bottom left corner of a room. Select the room's inside bottom right corner. This defines the width of the room. Select the room's inside top right corner. This defines the length of the room. The resulting dimensions are displayed in the Room Dimensions dialog. Click the Text button in the dialog and select the dimension style. Then click OK. The room dimensions are automatically inserted in the center of the room. Next, we'll use the Text tool to label the rooms in the design. Select Tools, Text, Text. In the Text dialog, click Text Style. In the Text Styles dialog, select the Labels text style and then click OK. Back in the Text dialog, type Family Room in the Text Editing window. Enable the Multiple Text Insert checkbox at the bottom of the dialog. This will return you to the Text dialog after you have inserted the text. Click OK. The text is attached to your cursor. Insert the family room in the room below the kitchen. In the Text dialog, make sure the family room text is highlighted. Double-click the kitchen label in the list of predefined labels. The family room text is replaced with kitchen text in the text editing window. Click OK. Insert the kitchen text in the kitchen. Then you can go ahead and label the other rooms in your model. Then click Cancel in the Text dialog once you are complete labeling all of the various rooms in the model. You can edit the style or content of text after it has been inserted. Click on the family room text to select it. Then right-click and select Properties, or simply double-click the text. In the Text dialog box, change the text to Living Room. Then click OK. The text updates in the drawing automatically. Save the drawing. You can use the Area Perimeter tool to instantly view the square footage and perimeter measurements of your design. Select Tools, Analyze, Area Perimeter, or select the Analyze Toolbar tab and click the Area Perimeter button. The dialog has two tabs, one for area measurements and one for perimeter measurements. You can print the calculations by clicking Print at the bottom of the dialog. Click OK. You've done all your modeling and design work. Now let's see how much the project will cost. Select Tools, Analyze, Generate Project Estimate, or click the Generate Project Estimate button on the Analyze toolbar. Your project estimate is displayed. The project estimate, or bill of materials, lists all the materials used to create your model. It lists information like the quantity, unit price, and total cost of each material, as well as the total cost of the project. You can control what information is reported, how it is reported, and specify custom material pricing. You can select a different report template from the drop box to generate a different report file type. Some templates generate files that can be opened in external estimating programs. When you're ready to start creating your construction documents, you need to switch to Worksheet View. Before switching, it is a good idea to make sure that your model is as complete as possible and that any elements that you want displayed in your construction documents are turned on in Model View. Select View, View Filters, View Filter, or click the View Filter button on the View Control toolbar. In the View Filter dialog, turn the roof back on and click OK. Just below the drawing area, there are several view tabs. We are currently on the Model View tab. Select the One Floor Plan tab. You're now in Worksheet View. The Insert toolbar contains the tools you need for setting up the main components of your worksheet. Use the Define Smart View tool to bring in a view of your model, such as a 2D plan or elevation. Use the Import tools to bring in outside CAD files in DWG or DXF format, PDFs, or image files such as JPEGs and bitmaps. To save time, you can use the Define Block tool to capture a group of objects in a block that can be saved and then inserted on other worksheets. The drawing area contains a generic drawing sheet border and title block that you can delete or edit to suit your needs. You can insert any predefined or custom title block, as well as various views of your model. From there, you can edit, detail, and annotate your drawing to create a detailed, accurate construction document. In Worksheet View, you can see crosshairs, which are lines that represent the two coordinate axes. At the center of the crosshair is a pick box, a square used for selecting objects. When you move your pointer outside the drawing area, you see a cursor, an arrow, for accessing menus and toolbars. The cursor can also become a double-headed arrow when resizing windows. The Object Properties panel displays the properties of the currently selected object, such as the layer it is assigned to. You can edit properties by simply making different selections in the panel. Let's create a floor plan drawing first. To do that, we need to insert a 2D view of the model onto our worksheet. Let's use the generic drawing sheet border and a title block for this exercise. With the Floor Plan View tab current, select Insert, Smart Views, Define Smart View, or click the Define Smart View button on the Insert toolbar. On the 2D tab of the Insert View dialog, make sure that the location is set to ground floor. From the Scale drop box, select the 1/4 inch equals 1 foot scale. The scale is the ratio of units on paper to real-world units. In this case, that would mean that every foot of the physical model is represented by 1/4 of an inch on paper. In the insertion area, select the Drawing Radio button. This option inserts a vector image. Vector data provides useful information about the geometry in a drawing, such as endpoints, curves, and polygons. The image option inserts a raster image, like a bitmap, which can be resized. Click the Zoom Out button at the bottom of the dialog if necessary to zoom out until the entire floor plan, including the dimensions, are visible inside the window. Anything that is not visible in the preview window will not be visible when the plan is inserted on the worksheet. For this particular view, we want the roof turned off. So click the View Filter button at the bottom of the dialog, and then turn off the roof in the View Filter dialog. Click OK to return to the Insert View dialog. The roof is now turned off in the preview window. In the Insert View dialog, click Insert. The ground floor plan is attached to your cursor. Position the plan in the center of the drawing sheet, then click to insert it. There are 4 predefined worksheet views available, and you can create more if you want. Let's switch to a different worksheet, and then insert our elevation views on that sheet. Below the drawing area, select the To Elevations View tab. Select Insert, Smart Views, Define Smart View, or click the Define Smart View button on the Insert toolbar. In the Insert View dialog, select the Elevations tab. In the Datum Lines pane, set the datum line placement to Yes for floor level and wall height. This will place datum lines and measurements at the floor level and top of the wall. Make sure the entire elevation is visible in the preview window. Click Insert. Insert the front elevation in the top left corner of the drawing sheet. Use the Define Smart View tool, Insert Smart Views, Define Smart Views to insert the remaining 3 elevations on the drawing sheet. You can use the Boundary Hatch tool to apply patterns to areas of a drawing. Let's work with the front elevation and apply a shingle pattern to the roof and a brick pattern to the walls. Select View, Zoom Window, or click the Zoom Window toolbar on the View toolbar. Click and drag a selection window around the front elevation. Then release your left mouse button. This zooms in on the front elevation. Select Draw, Boundary Hatch, or select the Draw Toolbar tab and click the Boundary Hatch button. In the Boundary Hatch dialog, select Roof Shingles from the Style drop box. Click the Select Boundaries button. This takes you back out to your drawing. Click anywhere inside the roof surface. The boundary highlights green to indicate that it has been selected. Right-click and select Enter. Back in the Boundary Hatch dialog, click Preview to see what the hatch will look like. Press Escape or right-click and select Cancel to return to the Boundary Hatch dialog. Click OK to apply the hatching to the roof. Select the Boundary Hatch tool again, and this time select Brick Pattern. Click the Select Boundaries button and then click inside the wall in the elevation. Right-click and select Enter. In the Boundary Hatch dialog, click OK. Here's a tip. You can insert elevations that are already hatched by setting the display mode to Pattern in the Insert View dialog when inserting the elevations onto your worksheet. The patterns applied depend on the material settings in each element's properties. Now let's switch to another worksheet and insert the section we created earlier. Below the drawing area, select the 3 Details View tab. Select Insert, Smart Views, Define Smart View. In the Insert View dialog, select the Sections tab. From the Scale drop box, select the 1/2 inch equals 1 foot scale, which is a common scale for building sections. Make sure that the entire section is visible inside the preview window. Then click Insert. Insert the section in the center of the sheet. Save the project. We've just completed the Quick Start tutorial. By completing the tutorial, we learned about model building, zooming and view control, 3D viewing and navigation, elevations and sections, estimating, annotation, landscaping, creating construction documents, and 3D real view rendering. With these new skills, you can start creating your own designs.